Alrighty, section 5.5, use inequalities in triangles. We are shifting away from centers and all that type of different things to comparing within a single triangle. So our goal today is find possible lengths of a third side of a triangle, is the biggest thing. We're going to start with talking about triangle inequalities. The first one is the shortest side is opposite the smallest angle. You can also say the longest side is opposite of the largest angle. What will happen is you will be given two sides or two angles and asked to compare them. So like on this first triangle, this side here, IJ, is opposite of H. And HI is opposite of J. Which angle is going to be larger? Well, which side is longer? 8 is greater than 5, so angle J is greater than angle H. Why? 8 is greater than 5. My suggestion to you, always write the larger angle first so that you do not confuse the less than sign with the angle symbol. It's happened before. So when looking at this triangle on the right, we are given the angles. Same thing, which side is going to be longer? Well, 50 degrees is bigger than 30 degrees. So which angle, so angle L is 50, so the side opposite is KM. So KM is greater than, and then the side opposite of KM is, of angle M is KL. When doing these, one thing I always note and go through with people, if you're using angle M, there's only two other vertices on the triangle. Those are the two vertices that make up the endpoints of your segment. So if you're saying this is angle M and angle L, KM, I need all three letters in here. So I have angle L, so I need to be using point KM. So list the sides and angles from smallest to largest. Yes, you are going to need to solve and find the measure of the unknown angle of the triangle first. So we have 30 plus 40 plus k, subtract 70 from both sides, we get 110 equals k. So that angle is 110. Since we are given angles, I would do the angles first. So, and again, make sure you read, because sometimes it says greatest to least, or least to greatest, or largest to smallest. Make sure you read the problem. So, smallest to largest, the smallest angle is angle M, angle L, and then angle K. And again, especially dealing with angle L, try and make your angle and your L's look different. Alright, now by sides. What side is opposite of M? Well, that is KL. And again, I'm looking using all 3 points. So without even looking at the triangle, I can say if it's triangle KML, I have angle L. That must be side KM. And then if I have angle K, I'm talking about segment LL. The triangle inequality theorem. The sum of any side lengths is greater than the third. In order for it to be a triangle, any two sides added together has to be longer than the third side. If they're equal to, you still have a segment. So how this works is you take any two segments, so say we go HI plus ij is greater than jh. And just work your way around. ij plus jh is greater than hi. And lastly, jh plus hi is greater than ij. So no matter what pair of segments you pick, they need to be longer than the opposite or the third side. A note on this, you will be given 2 or 3 of the lengths. Really, if you're just trying to say, is this a triangle, you only need to check the smallest 2. So if you had a triangle that was sides 3, 4, and 6, you only have to check, is 3 plus 4 greater than 6? Because we already know that adding 6 to anything is going to be greater than 3 or greater than 4. So we only check the 2 smallest sides. You can check all 3 of these, but you only need to check the smallest 2. The other type of problem you will get with this is find possible values. So here, find the possible values of x. So we have to look at, what if x is the shortest side? How short could it be? Well, we know 6 plus x has to be greater than 11. So we say 11 minus 6 has to be less than x. So x is greater than that. And we find that 5 is less than x. The other question is, what if x is the longest side? How long could it be? Well, 11 plus 6 still has to be greater than x. So we say that x is less than 11 plus 6, which is 17. So x can be anywhere between 5 and 17. My suggestion to you, instead of really making these problems harder and looking back at all those 3 inequalities and trying to determine which 1 or 2 you're using, it's simply a matter of take the values, subtract them, is less than x is less than, then I add them. And it's as simple as it is when doing these triangle inequality where it says find the possible values or find the range of values. That's all you're doing. Here are 2 more examples. Describe the possible length of the third side of the triangle given the length of the other 2 sides. Again, it's just a matter of going, I'm given 23 inches and 11 inches. So 23 minus 11 is less than x is less than 23 plus 11. So I get 12 inches is less than x is less than 34 inches. And that's my possible range of values. And we look at our last example here is 3 feet and 40 inches. If you look closely, you will notice you do not have the same unit. So step 1, cross out 3 feet and convert it to 36 inches. And then just as before, we could have 4 inches is less than x is less than 76 inches. These triangle inequalities are not very difficult. The biggest thing is watching for units when units are not the same.